modulating signal from amplitude modulated wave. Means extracting the modulating signal from amplitude modulated wave is called as AM demodulator. It's called as AM demodulator. Reverse of modulation. I should take back that modulating signals. How to take back that one? So the overall circuit will be off like this. So first this antenna, receiving station, or in your mobile, the antenna which is present, that is what? This will also have resistance. L1, okay, this you write it here, L1, C1. So here the programs radiated from different stations will be like this. So you write FA, FB, FC, FD. What are these? Programs radiated by different radio stations. So they'll come and strike the antenna. But I should pick up only the station. For that, I'll adjust the value of L1, C1. So this is called like a tuned circuit. Tuned circuit that selects desired carrier frequency or station, you write it better. Or station, I think in the mobile, no, 88 megahertz. Just you directly tune it, no? As you tune for different circuits, so what you're tuning, you're going to tune this. Don't think in mobile you are changing capacitance. This is what analog. Your mobile is what software. It's based on software. There's no circuit will be there. There's a trick. What you are in mobile is there, no? The FM station, what you're listening, no? Very small chip it is. The technology got improved. When high used to listen FM or AM, no? Like a box, the radio set, it used to be like a, you can say like a similar to the tab or like that, of that much of size. So now the technology got improved and everything has become digitalized and you don't see any of this one. Only antenna will be there. The rest, everything will come by other method. It's a totally digital electronics, that one. Okay, I'm just giving example, like tuning means selecting different radio stations. So there's a diode. I'll push it down a little bit. So there's a loudspeaker and here you get that song which we transmitted. Okay, what about the first, what happened? The wave, what all that wave is there? It will come like this. The amplitude modulated wave, no? And we show it. Look at its amplitude, it's varying. So by adjusting the frequency of the tuning circuit, I can select the station A, station B like this. Okay, I got amplitude modulated wave. This is what you write, VM. I'll pass through a diode. It's like some sort of a rectifier, no? It is similar to a rectifier circuit. It will eliminate the upper envelope. So what it does, it will eliminate half of the one sideband. It will eliminate one of the sideband. So still call, don't write VAM by 2, call amplitude modulated wave only. We are just, don't say half sine wave. It's a envelope, that one. Upper sideband, lower sideband. One of the sideband is got element. You can choose whichever you want. Now, next after this, what this filter, finally, the output of this filter will be, there's a filter. So what do we get? We get a signal. The DC signal. Okay, that's in black color. This is the original modulating signal. Then where the carrier gone? The carrier, if you want, you can show it here. The carrier is being pushed down here. The carrier will be. So it's like a, shall I call this a filter? So what it's doing, it is emitting high frequency, it is allowing low frequency signal, modulating signal, low frequency signal. So since it's having some DC voltage, some DC circuit I'll bring where it will nullify the DC voltage, and finally what we get the required our signal of this kind. And when this given to loudspeaker, okay, the song which you want to hear, you are going to hear that one. So the loudspeaker will convert the AC signal to sound wave. No, what are the conditions like? The tuning circuit, what's with it? The desired station frequency you can select by using this. So if you remember that formula, LC oscillations, can you remember which particular station you want to hear? Okay, adjust the frequency of this circuit to that particular desired station frequency. Only that particular station signal will pass to, the remaining will be rejected. From where? How do I reject? Parallel resonance circuit. Here acceptor or rejector circuit. I think I need here like a resonance series resonance circuit here. So, but sir, like you are connected parallel. So there's an overall circuit, the signal will get feeded up here, and I'm going to collect it from this circuit here. So what is this? If the frequency of this circuit, if it becomes equal to frequency of this, only that signal power will be increased. The remaining signals open, they'll just pass through it here. Okay, this is called a tuning circuit. It's not there in NCERT book. I don't know missing, but possibility of asking. That's a point. There's a diode. What it will do? It will eliminate either upper and lower off. And what is this? This is called like a low pass filter. It will allow modulating signal and this particular, and it will block the carrier signal. The carrier signal will flow to the ground. Then just you can't say that, okay, so I have these values. So we have very, I don't know why suddenly they have asked this in exam. For any value of R2, C2, no, even the mu will also come into picture. So when this modulating signal will be successfully recollected, only when this circuit satisfies this condition. Means here the modulating signal will be there, no? So what is modulating signal? 20 to 20 kilohertz. It should satisfy all that. Then what is mu? Even the modulation index, we must have a guess. So like we have sent the amplitude modulation, we are done with 0.9. The 0.9 has to be kept here. If mu less than 1, as mu is less than, this approximated formula will become 2 pi mu. This is what asked in mains. No book at our level. What is their anxiety or SMA, what all you book, no, nothing is discussion is there. But the weekend exams, what we give, no, in the grand test, no. So accidentally, what we have just included this, and luckily in that year this question came, and our students were comfortable. So definitely, what many objected to be deleted. We told, okay, have let's that one, and like in that year, luckily it appeared in mains exam. So the demodulator circuit successfully to retain what happened, the FM. So they given FM. We know FM. What is FM? FM is around so like a modulating signal 20 kilohertz, substitute 20 kilohertz. Then what should be the value of, we have given mu C2. Everyone without this formula, they were guessing with this, and there was an option for this also. You'll go wrong because the mu has to be brought. And this is approximated formula. When mu is less than 1, usually mu will be less than 1. If mu equal to 1, it should not be, mu will never be 1. But sir, you only said 100%. No, mu, I'll slightly make it less than 1, 0.99. So therefore, this is approximated formula what we use in designing of circuits. You have to remember. This is a wrong thing. I'll erase it. Why mu should not be equal to 1? Again, you have to go back to the EM circuit. I'll show it. Is it okay? So this is called like an amplitude demodulator. So what all we have? Tuned circuit, diode, low pass filter, means which are low frequencies, block high frequencies, and the loudspeaker. And this filter should satisfy this equation for successful recollection of modulating signal. Sir, what happens if this equation is not satisfied? You may hear song, but lot of disturbance, noise will get added up, distorted. Something will be missing. The complete song, so here and there, some breakups will be there and distortion will be there. We just call distorted. If this equation is not satisfied, it will be distorted. Now let's come for why mu should not be equal to 1. If you come for this, practically what will happen, the sound will get added up, no? The noise will get added up everywhere in the circuit transmission. If I make mu equal to 1, if the noise gets added up, because of that, what we get is of this kind. If mu is greater than 1, so some books they have shown nothing wrong. They have shown it like this. If mu becomes 1.2, 1.3, no, this negative off cycle, this positive off cycle will overlap here. Negative off cycle will come here. Then what happens? We end up like this. So mu is 1.5 like that. So this is distorted. This was not our signal. Our signal should be of this kind. So what is our signal? This is not our signal. No? I think the modulating signal, how it is. The modulating signal is this one. Then if you produce signal of this kind, I think these two are not same. No? This what happening here. Go that here. So mu greater than 1, it can be like this also. Some books they are shown. So in the end, I wanted to show it here. Gap will come, or you have to show this. Okay, fine. Now if you make mu equal to 1, some noise will get added up and it will make signal like this. And it will be noisy. So therefore, slightly I'll make mu 0.99. The noise which gets added up will make it equal to 1 and will be transmitted. This idea of this one practically will never make it 1. If I make it 1, the mu will become, after modulation will become greater than 1. So therefore mu should be 0.99. It should be maintained so that anyway the noise will get added up to the system, and when noise gets added up, it will become 0.998 like that, almost equal to 1. We are able to retrieve it. See, mu less than 1, information is lost. The mu, I'll adjust this one. Theoretical questions can be asked here. So the noise, what happens, will get added up. So therefore mu is slightly made less than 1 practically. Any doubt? If you have, you can ask it. Okay, wait, I think one. Okay. One more is the last information. One more last, we'll wind up. One more last. So practically, if you see, no, in the radio station, so especially FM, no, you'll get even background music also, no, the speech and background, that one. So what we do is like modulating signals will not be this will be VM1. More than one modulating signal is what practically we apply. This will be correspond for speech. This will be for music. And there's a carrier. I'm going to simultaneously modulate this carrier by more than one modulating signal. I'll mix up this, called a mixing up, that one. I think if you go for FM station, no, so it'll be like that, the speech, music. The person what all is speaking, background music will be there, background music. I think in movies, background music, what you know, The same thing happens in radio station. The background music should be there. Then only it's become more attractive. You listen for FM, you can see that background music they'll be generating. So what we do modulate. So when you modulate, the modulation index will become like this. And so on. Like this, you can use any number of modulating signals and you can modulate a carrier. And this carrier now contains both speech and music. So how to calculate mu1? Mu1 is given by A1 by AC. Mu2 is given by A2 by AC. So this will be the effective modulation index. So what is this? When carrier is modulated by more than one carrier. When carrier is modulated by more than one modulating signals. Then the effective modulation index, the formula will be this one. Now, very important because this will never send only speech or only music. Everything will be there. Any doubt you can clarify? Any doubt? A little bit because most of things are very new for you. Any doubt? If you have, you clarify. I'll wait.